Data centers need a new kind of air conditioner, the future of HVAC explained. Imagine buying the world's fastest supercomputer. Now imagine trying to cool it with the same air conditioner that's used in an office. It simply wouldn't work. Today, artificial intelligence is changing everything. From ChatGPT to self-driving cars, AI is becoming more powerful every day. But behind every AI breakthrough lies a massive engineering challenge. Heat. Modern AI servers produce so much heat that traditional air conditioning is reaching its limits. That's why engineers are developing an entirely new generation of cooling systems, liquid cooling, immersion cooling, and data centers unlike anything we've seen before. In this video, we'll explore why AI data centers need a new kind of air conditioner and how this technology is changing the future of HVAC forever. Let's begin. Chapter 1: The AI Revolution. Every time you ask an AI chatbot a question, generate an image, or translate a language, thousands of powerful processors begin working instantly. These processors are called GPUs. Unlike normal computer processors, GPUs are designed to perform thousands of calculations simultaneously. That makes them perfect for artificial intelligence. But there's a problem. More computing power means more electricity, and almost every watt of electricity eventually becomes heat. A modern AI GPU can consume over 1000 watts during demanding workloads. Now imagine placing dozens of these GPUs inside a single server. Then imagine hundreds of those servers inside one room. One AI rack can consume over 100 kilowatts of power. That's nearly enough electricity to power dozens of homes. Every bit of that energy turns into heat. Without cooling, these expensive processors would quickly overheat, slow down, or fail completely. Cooling is no longer optional. It's absolutely essential. Chapter 2: Why traditional air conditioning fails. For decades, data centers have relied on air conditioning. Computer room air conditioners, commonly known as crack units, produce cold air. Large fans push this cold air through the server racks. The servers absorb the cool air and expel hot air out the back. It sounds simple, and for many years it worked perfectly, but AI changed everything. Modern AI servers generate far more heat than older computer systems. To remove that heat using only air, engineers would need enormous fans moving incredible volumes of air. More fans mean higher electricity consumption, more noise, more maintenance. Eventually, air reaches its physical limit. No matter how powerful the fan becomes, it cannot remove heat fast enough from today's AI processors. That's why engineers began looking for a completely different solution, not colder air, but liquid. Chapter 3: Why liquid is better. Have you ever noticed how your car engine uses coolant instead of air? The reason is simple. Liquids carry heat far more efficiently than air. Instead of blowing cold air across the processor, engineers place a metal cold plate directly on top of the chip. Inside this cold plate, chilled liquid continuously flows through tiny channels. As the processor becomes hot, the liquid immediately absorbs that heat. The warm liquid then travels to a heat exchanger. There, the heat is transferred away before the cooled liquid circulates back to the processor. This process repeats continuously. The processor stays cool, performance remains high, and much less energy is wasted moving air around the room. Liquid cooling allows AI processors to operate at much higher power levels while remaining safe. Chapter 4: Immersion cooling. Now imagine removing every cooling fan inside the server. Instead, place the entire computer inside a tank filled with a special liquid. Sounds impossible? It's already happening. This technology is called immersion cooling. The liquid isn't ordinary water. It's a specially engineered dielectric fluid. Because it doesn't conduct electricity, electronic components can safely operate while completely submerged. As the processors generate heat, the liquid absorbs it directly. The heated liquid flows through a cooling system. After cooling down, it returns to the tank. This approach eliminates many fans, reduces noise, lowers energy consumption, and can support even more powerful AI hardware. Some experts believe immersion cooling will become one of the most important technologies for future AI data centers. Chapter 5: The Complete Cooling System. Cooling an AI data center isn't just about the server. Behind the scenes is an entire HVAC system working together. Cold plates remove heat from the processors, pumps circulate the coolant, heat exchangers transfer thermal energy. Chillers cool the circulating water. Cooling towers reject heat to the atmosphere. Sensors constantly monitor temperatures. Building management systems automatically adjust pumps, valves, and cooling equipment every second. Without this sophisticated HVAC infrastructure, artificial intelligence simply couldn't operate reliably. Chapter 6: The Future of HVAC. The rise of artificial intelligence is transforming the HVAC industry. Tomorrow's engineers won't only design comfort cooling for homes and offices, they'll design precision cooling systems for AI factories. Future HVAC systems will become smarter, more efficient, more sustainable, and increasingly controlled by artificial intelligence itself. Liquid cooling, immersion cooling, and advanced thermal management are becoming the new standard. The future of HVAC is no longer just about cooling buildings. It's about enabling the world's most powerful computers. Artificial intelligence may seem like software, but behind every AI breakthrough is a massive cooling system working around the clock. Without advanced HVAC technology, the AI revolution would literally overheat. Welcome to our channel SR HVAC. Subscribe for more futuristic HVAC engineering content. If you enjoyed this video, don't forget to like and tell us in the comments. We have a lot more informative content coming your way. Thanks for watching. Which cooling technology do you think is the future? Traditional air cooling or liquid cooling? Let me know in the comments below. Thanks for watching. I'll see you in the next video.